Problem number 1 asks us to find the area of the region bounded by y equals sine x and y equals cosine x from the y-axis to their first point of intersection in the first quadrant. So obviously I'm going to start here by creating a graph of these two functions in the first quadrant of the coordinate plane. Fortunately, we should know what sine x and cosine x both look like, so this shouldn't be too hard. And I know that if we're talking about in the first point of intersection in the first quadrant, this intersection is going to happen before pi over 2, because that would be the first quadrant of the unit circle. So going out to pi is plenty on our x-axis. And obviously we have an amplitude of 1 and -1 on the y-axis. Okay, so I'm going to start by graphing sine x first. We know sine is the wave, and we know that if we're just looking at it basically from 0 to pi, we're just looking at half of, one trip around the unit circle. So sine x starts at 0 and crosses the x-axis again at pi, and it's at its maximum amplitude at pi over 2. So this is what sine x is going to look like from 0 to pi, and it keeps going. And then cosine x, we know, looks like our cup, and that one starts at its maximum amplitude, which is 1, and it crosses at pi over 2, and it's at its minimum amplitude at pi. So this looks like this. And this is y equals cosine x. So obviously we can see here that the point of intersection is right here. And so the area that we were talking about in the first quadrant that's bounded by these two graphs is going to be this area right here that we are trying to find. All right, so thinking about this in terms of an integral, we know that our area is going to be equal to the integral of, and then when we look at our graph, cosine x is on top, right? That is the upper function, and sine x is the lower function. So this is going to be integral of cosine x minus sine x dx. And then as far as the limits of integration are concerned, well, the intersection point right here is at pi over 4. So this goes from 0 to pi over 4. Now we can see that in the graph that I drew. You could also use your graphing calculator to figure that out, right? You could calculate the intersection using your graphing calculator. But also, when you think about the unit circle and you think about the ordered pairs that are in the unit circle, at pi over 4, that's where sine x and cosine x both have the same value, right? It's square root of 2 over 2, square root of 2 over 2. So that's the point of intersection. It's where sine x and cosine x have the same value. All right, so now we just have to anti-differentiate and then do the evaluation theorem. So this is going to be equal to the antiderivative of cosine is sine, and then the antiderivative of negative sine x would end up being positive cosine x. And we are going to evaluate this from 0 to pi over 4. So doing the evaluation theorem, this is going to be the sine of pi over 4 plus the cosine of pi over 4 minus sine of 0 plus cosine of 0. All right, and then we know that sine of pi over 4 is square root of 2 over 2, and cosine of pi over 4 is square root of 2 over 2. And then sine of 0 is 0, and cosine of 0 is 1. When I distribute the negative, that's going to become a -1. So I end up with square root of 2 over 2 plus square root of 2 over 2, which would be 2 square roots of 2 over 2, or just square root of 2, minus 1. So there's my answer in its exact form, and that's how I'm going to leave it. Of course, a decimal approximation is fine. Just make sure you're rounding to 3 places past the decimal. In problem number 2, we want to find the area of the region shaded in the graph. Now, this is one of those situations where looking at this, it's obvious to see that this is going to be easier for us to integrate with respect to y than it is going to be for us to integrate with respect to x. The blue graph here, the sideways parabola, that's already in x equals form. The other function, which is just that red line, which is a linear function, y equals 1/2 x minus 1/2, I can easily make that look like x equals. I'm just going to do that algebra down here. So if I have y equals 1/2 x minus 1/2, and I just start by multiplying the whole thing by 2, then I'm going to have 2y is equal to x minus 1. And then to get x alone, obviously I'm just going to be adding 1 to both sides. So 2y plus 1 is equal to x. So there's the equation of my red line. And we know that when we are integrating with respect to y, it's always going to be the right function minus the left function. Okay, and then our limits of integration obviously are going to be our y values of our points of intersection. So if I set up my area integral is going to be equal to, my limits of integration will be from -3 to +1. And then again, it's going to be the function on the right minus the function on the left. The function on the right, the blue function, is -y squared plus 4 minus, and then the red function is my x equals 2y plus 1. And we're integrating with respect to y, so dy. And then, of course, I'm going to distribute the negative, and I'm going to combine like terms before I anti-differentiate because that makes my work easier. So -y squared plus 4 minus 2y minus 1 dy. And I can combine the constant terms in that expression. The 4 and the -1 are going to make 3, so I end up with the integral from -3 to 1 of -y squared minus 2y plus 3 dy. All right, so now I'm ready to anti-differentiate this. The antiderivative of -y squared is going to be -1/3 y cubed. The antiderivative of -2y is going to be -y squared. And the antiderivative of 3 is going to be +3y. And I am evaluating this from -3 to +1. So then I go ahead and I do my evaluation theorem. So -1/3 times 1 cubed minus 1 squared plus 3 times 1 minus -1/3 times -3 cubed minus -3 squared plus 3 times -3. And then I just have to do the math. 1 cubed is 1 times the -1/3 is -1/3. 1 squared is 1 times the negative is -1, and 3 times 1 is 3. And then -3 cubed is -27. -27 times -1/3 is going to be +9. I'll distribute the negative in the next step. -3 squared is 9 times the -1 is -9, and then 3 times -3 is another -9. So essentially, those two cancel each other out, and then the -9 is going to be a +9. So I end up with -1/3 minus 1 plus 3 plus 9. So we get 12 minus 1 is 11. 11 minus 1/3 is going to be 10 2/3 or 32 thirds.